Welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are going to start a new lecture on design part, design of immersive experiences. So, earlier we talked about methods for user requirement gathering. So, earlier we talked about how to gather usability requirements, or in other words end user requirements, and also how that idea was used in our case study. In particular, how we identified issues that are relevant, that are to be addressed to make our Majuli VR tour usable. In this lecture, what we are going to do is basically to learn about designing the experience, particularly interface and interaction design. So, if we quickly have a relook, or if we quickly recap the interactive system development life cycle, the stages, you can see there are several stages: feasibility study, starting with feasibility study, then requirement gathering, analysis and specification, then this design, prototype and evaluate cycle comprising of design, prototyping and early evaluation. Then we have code design, followed by coding and implementation, followed by code testing, which is followed by empirical study or empirical testing or usability testing. Finally, deployment and maintenance. In between there are lots of feedback loops. So, one between here, then we have this loop, then we have this loop, then we also have this loop. So, lot of feedback loops are there. Out of these, we have already talked about requirement gathering stage. Note that there are two design stages. One is the design mentioned in this part and the other one is code design. So, here we are going to talk about the design stage of design, prototype, evaluate cycle, particularly related to interface and code design, interface and interaction design, interface plus interaction design. So, we are going to talk about that part in this lecture. So, SDLC include code and system design as well. However, we will not focus on code design here. Again, I am assuming, like in case of functional requirements, I am assuming that you are already familiar with that stage, or how it is done. And here in case of interactive system development life cycle also, it is the same as in any other software. So, there is no difference between code design here and code design for any non-interactive software development as well. So, we are not going to separately discuss that. So, let us start with the basic concepts of design as in interface and interaction design. So, when we talk of experience, designing the experience, immersive experience, it involves the entire design, prototype, evaluate cycle in order to incorporate the user requirements. Now, in this lecture we are going to focus on the design part. In the next lecture, a separate lecture, we will be talking about the two components, namely prototype and evaluation. So, here in this lecture our focus will be only on the design part. Now, when we talk of design, design of interface and interaction, there are two issues. First is where to start, how do we start the design process, and how to represent whatever we have designed. In other words, we can say we need to have a design language to express our design. The first thing is to start the process, and second thing is whenever we are coming up with a design, how to express it so that we can brainstorm on it or we can refine it. Let us first talk about where to start. Of course, generally it is assumed that this is part of a creative thinking process. So, we can rely on our creativity, which may be aided by intuition. Also, it can be aided by experience or domain knowledge. That is, of course, if we have nothing to rely on, then we can rely on our creativity, which can be aided by our intuition or the expertise or experience or domain knowledge. It can also start with some guidelines. So, we can also think of starting the process based on some guidelines or thumb rules or checklists or heuristics. These are known by different names. So, those can act as starting point to aid our creative thinking. So, of course, interface interaction design requires creativity, imagination. Along with that, we can take recourse to some guidelines, often called checklists, heuristics, thumb rules, and so on. Now, there are many such guidelines. Some are very generic and consequently small in size. They are very broad in nature, and number of guidelines is generally small. So, they cover broad aspects of interactive systems at a rather high level. Examples are 8 golden rules by Schneiderman, primarily meant to take care of graphical user interfaces, but those are so generic that can be applicable to other cases as well. Similarly, the 7 principles by Donald Norman. Again, it was designed in the 1980s, developed in the 1980s, primarily meant for GUIs, but again, because of the generic nature, it can be applied to other domains as well. There are other more detailed and specific set of guidelines available. They are generally large in number because they cover micro details of a particular system. So, to cover minute aspects of the design, they are generally large in numbers, and they are typically meant for specific products. For example, the human interface guidelines originally developed by the Apple systems for their user interfaces. That is about starting point. So, we can start with our creativity aided by experience or intuition or some guidelines. Even we can rely on all the three. Then there is this language. How do we express whatever we are thinking? So, this essentially refers to a specification of design. Note that earlier we talked of specification of requirements, now we are talking of specification of design. There can be different languages for specifying the design, and generally specification of interface design, the language used to specify interface design are likely to be different than the language used to specify code design. Now, to express interface and interaction design ideas, we can take recourse to prototypes. Now, prototypes in a sense can be thought of as a language to express our design ideas. So, can be considered language for interface design. However, we will talk about this language in the next lecture, not as part of this lecture. In a subsequent lecture, we will talk about prototypes for interactive systems, different categories and how they can be utilized. Let us now talk about the starting point. How do we start the design, where we have our creativity, we have our imagination, but along with that we can make use of design guidelines. So, let us talk about design guidelines. So, as mentioned earlier, we have specific guidelines as well as generic guidelines. In an earlier lecture, if you can refer to module 1 lecture number 12, we learned about some specific guidelines to be followed for avoiding or minimizing cyber sickness. These are typically applicable for VR or immersive systems, where immersion is a very important issue. Now, since AR the notion of immersion is different than those that are applicable for VR. So, those cyber sickness guidelines may not be specifically applicable for AR systems. So, that is an example of a specific guideline set. In this case, it is VR specific guidelines to avoid cyber sickness, one specific aspects of VR. Also, we can talk about generic guidelines which are applicable for any interactive system including XR systems. Later on we will see that may not be fully applicable, but mostly applicable to extended reality systems. So, let us talk about the one such generic guideline, that is the 8 golden rules by Ben Shneiderman. Now, it was, as I mentioned earlier, it was originally developed in 1986, about 40 years back, and it was primarily meant for GUIs, graphical user interfaces. It is a set of 8 rules or guidelines. It can be partly or fully applicable for other types of interfaces as well, including extended reality systems. Once we go through the guidelines, you can judge for yourself whether these are applicable for any extended reality systems. Let us talk about the 8 rules that are part of the golden rules of Shneiderman. Let us start with rule number 1, which says that strive for consistency. So, whenever you are designing an interface, you should always strive for consistency. There must be consistency in your design. What it means? There are 2 types of consistency. One is internal, one is external or environmental consistency. Internal means whatever elements, whatever interactions that you are using in one part of the design for specific tasks, the same thing should be utilized in other parts of the design for the same task. So, in different design different usage instance for the same tasks, separate objects, separate elements or separate interactions should not be utilized. That is internal consistency. There is something called external consistency as well, that is, so whenever we are using a system, we come with some real world knowledge. So, when we are using a system, that knowledge should be as closely matching with our experience with the virtual world as possible. So, real world knowledge transfer to the virtual world should be as close as possible. That means, the elements that we deal with, the interactions that we perform should be close to our real world experience as much as possible. So, that is consistency, external consistency. Rule number 2 is design for universal usability. So, if you recollect, earlier we talked about knowing the user, and we also talked about a broad categorization of users. We saw that there are 3 broad classes of users: novice, intermittent and expert. Novice means first time user, first time user. Intermittent refers to occasional users, and expert refers to frequent users. Now, note that here the term expert does not mean expert in technology, rather expert in usage of the system. Now, typically when we design, we should have facilities for all classes of users. Let us take one example. So, we all have used some sort of word processor to type, to save text, to create text document, to save text document and so on. Now, suppose we are using such a word processor system to create a text document and we want to save it. Now, saving can be done with hotkey, that is a combination of keys. Say for example, Control plus S, that can be used to save a document. Also, we can save a document using a menu option like save. Now, why to keep both the options in a single system? The reason is, one option is meant for one type of user, another option is meant for another type of user. Those who are experts, they typically do not want to use menu based option because that is slower. So, they will be going for hotkey or the Control plus S option, which are faster. Whereas, those who are novice or intermittent, they may not remember the hotkey combination. So, for them menu based option would be better because that relies on recognition rather than recall, which is a skill task. So, typically we should aim to design systems that support different user categories rather than specific category. Then rule number 3 says that we should offer informative feedback to the users. Whatever action user does, some informative feedback should be given to the users. For example, we are already familiar with the notion of progress bar. When we install something or we do something, sometimes the progress bar appears to show the percentage of task completed. So, that is giving the user some sense of how much longer the user has to wait before the task completes. Now, if we are not showing the progress bar, user will be at a loss to understand what the system is doing, whether the task is getting done or not, how much of the task gets completed and so on. That is not good for usable design. Similarly, typically to save a file, we get to see that after the saving operation is done, if it is done successfully, then there is a color change on a image icon that shows a floppy disk, an earlier storage device instance. It used to be the case in most desktop applications even a few years ago that there is a color change. It still is there. Now, floppy of course is a storage metaphor representing the storage. So, before save there is one color, after the save operation is done there is another color. Now, this color change indicates that the save operation is done successfully. Without this color change, user will be not in a position to understand whether the save operation worked or not. Then let us talk about rule number 4, design dialogues to yield closure. So, when user wants to achieve some objective, complete some tasks, the system should be designed in a way such that the user gets a feeling that the start is started, executed and finally completed. So, some sort of dialogue should be there to indicate to the user that the task is now completed. So, that feedback is related in fact to the rule number 3, previous rule, and it advises the designer to organize activities into groups having a beginning part, middle part and an end part. So, whenever you are expecting the user to perform a task to achieve some goal in your system, then that task execution should be designed in such a way that there is a beginning part of the task execution, a middle part and a completion or end part. And there should be some feedback at the end of each group. Say for example, in case of online shopping, if you are doing a shopping activity, there are lots of subtasks, and then if there is some grouping, that choosing items, putting it into cart, payment. So, if you actually organize the subtasks into beginning, middle and end part, then it will be useful for the user to use the system and understand the working, how to proceed to achieve the objective. So, it is always beneficial to have a system that is properly designed to let the user achieve a task with clear cut beginning part, middle part and end part of the process. Then there is rule number 5, which is offer error prevention and simple error handling. So, it is obvious and it is unavoidable that there will always be some error. To err is human, we all know. So, error cannot be totally removed from our consideration. However, we should try to have a design that lets the user make as little error as possible. So, that we should design to keep error rates low. So, for example, close and start options should not be kept close to each other. So, if we are keeping the close option for an interface and the start option for the same interface side by side, then instead of closing sometimes by mistake we can start it, or instead of starting sometimes by mistake we can close it. So, that is of course one very simple trivial example of how to avoid errors, how to design to avoid error, to prevent errors. But if error happens, we should not ideally show complicated message to the user stating that there is some error, then that will confuse the user, that will scare the user. Instead, the information should be simple, easy to understand language. So, rule 5 states that we offer error prevention in our design as well as something to handle with errors if it happens. In relation to this, there is another rule, rule 6, that is permit easy reversal of actions. So, I have made some mistakes, now I want to rectify it. So, the reversal of action that led to the mistake, that led to the error is an important design objective. Ideally, we should keep the reversal option there, so that user can come back from the erroneous situation. So, we all heard of the facilities called undo and redo. These are primarily meant for that only, that is permit easy reversal of action. Rule 7 talks about keeping the users in control, that is letting the user feel that they are in control of the system. So, this feeling is very important, otherwise the user will, because we are assuming the users are lay persons, they do not have much technical expertise. So, if we do not let this feeling go to the user, then users will feel at a loss, because everything is very technical, user will not like to use the system and usability reduces. So, users should be able to perceive their interaction, they should be able to understand, perceive that something is happening, and also that something is happening means change in system state, the user should be able to perceive. Say for example, when the user is performing a drag and drop operation on a typical desktop application, then user should be able to actually see that something is being dragged from one place to another, and also see or visually perceive that when the object is dropped, then it is dropped at the place, or it is being shown at the place where it is the user wants it to be, so maybe in another folder. So, it should be shown there. So, that is something that user should be made aware of, that the actions there should be feedback, and the result of the actions there should be feedback. Then we come to the last rule, that is reduce short term memory load. Now, this is a very interesting rule. It came from psychological experiments. So, our memory we can think of as comprising of two parts in a very broad sense, short term and long term. Short term memory is essentially kind of notes. So, when we perform some activities, we bring in some information from the long term or permanent storage, long term memory or permanent storage into the short term memory, which is non permanent storage, just kind of notebook sort of thing to aid our activities, day to day activities. Now, the finding originally proposed by George Miller in way back in 1956, almost 70 years ago, says that, so the rule was 7 plus minus 2 rule, which says that at a time in our short term memory, it is best to keep between 7 to 9, between 5 to 9 chunks of information. That is our limit. If we are trying to, of course, if we keep less, then we are underutilizing our memory, short term memory, and if we are trying to keep more, then we are overutilizing. So, keeping more is actually harmful. So, if we want the user to remember lot of things, recall lot of things from long term memory to short term memory in order to make the interface used, then certainly our physiology does not support that. So, in that case, it is likely that the user will not be able to use it. So, if we require more than 9 chunks of information to be utilized while operating an interface. So, our objective should be to keep the information required to operate an interface or perform an interaction between 5 to 9 for optimum outcome by the user. So, in short, we can say that we should not force users to remember too many things, where too many in this context quantitatively we can call more than 9 chunks of information. Chunks of information is essentially an unit of information. It can represent one letter, it can represent one word or a whole sentence as well, or a whole concept. It varies from application to application. So, these are 8 rules, and as I said before, these are quite generic in nature. They need not be specific to any product, any system. However, as we can see, they can be applicable to a broad class of interactive systems, and you can analyze and see whether or how much of those are applicable to extended reality systems. Now, let us move our focus to another aspect of design, which we will be requiring in subsequent part of this lecture, that is interaction techniques that are used in extended reality. Our primary focus will be virtual reality. Why we need to know this? Interaction in non-immersive settings such as AR is similar to interactions we are familiar with, such as touch, gesture, etc. So, there is nothing significant here. However, for immersive VR or MR experiences, specialized techniques and setups are used, and we should be aware of those in order to be able to properly design the experience. So, it is important to know and use suitable interaction techniques for enhanced presence. So, we need to know what kind of interactions are supported. Now, there are different types of interactions that are typically designed for immersive environments, immersive experience. One is object interaction, then navigation, thirdly interaction for system control. So, broadly 3 categories. Object interaction means selection and manipulation of objects that are part of the virtual environment. Navigation means moving from one point to another in the virtual environment, and thirdly interaction for system control means several system related settings, interaction required to change those settings. So, we will talk about these interaction types in subsequent part of the lecture. So, in summary, what we have discussed so far in this part of the lecture is, we talked about the idea of design, particularly interface and interaction design. We talked about design guidelines, that is the starting point. The design language we will be talking in the next lecture, a separate topic, that is a part of separate topic. We also briefly touched on the interaction techniques. The more details will be covered in the subsequent part of this lecture on design. So, we will continue on these interaction techniques in subsequent part. So, I hope I could explain the topics in a easy to understand manner. You are able to follow the concepts. We talked about design, design guidelines as starting points, and Schneiderman's 8 golden rules, their applicability on extended reality systems, and also started our discussion on interaction design. So, we will continue our discussion. Looking forward to meet you in the next part of the lecture. Till then, thank you, goodbye and happy learning.